Well, I've got plenty to do today. I've just made a list of all the things that I've got to do in my workshop today for the John Wall 24-inch telescope. And thank you very much, Minnie, that's very good. Can you move out of the way? And it's a very long list. Hopefully I'll get them all done. We've got to drill and tap the tube sprocket carrier, which I've already done. The sprocket for, I just need to drill and tap the holes that hold the sprockets on. I need to make the counterweight arm itself, and onto that we're going to have to make a boss, which needs to be drilled to 1 inch and broached for a keyway. We've got to mill key slots into the shaft itself to take that. I've got to then weld that onto the actual arm to stop it from rotating. We've got to then drill all the bracketry, so that needs doing still. We've got to extend the slot in the counterweight hanger. We've got to cross drill the counterweight pin for a split pin. Little jobs these, they're not too bad. We've got to make some spaces for the bracket bases, 4 of those. And last but not least, we've got to drill the finger plates for the door to take some rivets. So let's get cracking. Now in the this is the counterweight tube here, and through the top of it there's a pin which holds the suspend the counterweight off the counterweight arm. The pin itself, as you can see, is just a straight plain pin which is turned up. What it needs to stop it coming out of the hole is a split pin. So I got some split pins this week off good old eBay, and so all I've got to do is just cross drill that. These are 2.7mm split pins. So I need a 3mm hole drilling through there. I just need to make sure it's not going to interfere with the actual. Yeah, so through there's fine. I can put a washer on there as well, because I think that's 10mm. I've got some 10mm washers. So put a washer on there to stop it fouling the split pin and the split pin through there, and we'll be laughing. So probably just get a Sharpie and mark that. Let's find a Sharpie. There we go. So that wants to be, that's basically wants to be about there on that mark. Oops, there's my washer. 1 down, 9 to go. Pick that up, got back to 10 again. Right, so yeah, so I'm just going to drill through there a 3mm hole. So in order to cross drill this, the easiest way is to set the jaws at a distance whereby this settles nice and tight. Get a drill which is pretty much the same diameter, which that one is. So if I get that drill in there, so I've got I think it's a 7mm drill in there. It's a 10mm shaft for drilling, so 7mm. If we now get that into there, it's slightly too tight. If I get that into there so it's actually centered, which, let me just tighten it up a little bit, let me get it to its biggest diameter, which is there. So now that is centered on there. If I'm careful not to move that now, that's now centered on there. Ideally I should clamp that down, but I'm only doing one quick one, so should be able to keep it in place for long enough to just pop a mark in there. Of course, as soon as I do this, I'll catch it with my sleeve and it'll move. So if I lay this in here now like that, this drill now is going to come down centered. Of course, you can see exactly what I've done. As I said, a bit Mr. Bozo, as Tom Lipton would say. I need that to be a bit further that way so that I've got some leeway for doing that. Now, what I should do is probably just double check that, which I will. Otherwise, it might just be slightly off. It doesn't matter if it's wild it out. I mean, it is only for a split pin. There's no sort of precision requirement really, but just for peace of mind, that's pretty much centered there. So better than a drill would be some sort of pin, roll pin, some sort of gauge pin or something, but I haven't got any, so it's going to have to be one of these. So that's a better position. So now that's in position, you can see now that this is going to come down centered on the work, so somewhere around there is going to be absolutely fine. So change that for a 3mm and finish off. Okay, now that I've got it spotted and I've got this bit of anchor lube on there, I've decided to clamp it in this vise here. So it's only a small part. Okay, that's the hole drilled. Let's try the pin in just to make sure. There we go, nice fit in there, that's good. Right, so that's one job to cross off the list. Just clean that up with a file and on to the next job. So this is the bracket that is going to go on the roof. This is there are two of these that hold these bearing blocks. So that's going to go on there. So all I've got to do now is just drill some holes in there. So these are slotted for a slight adjustment. So I'm just going to mark those pretty much by eye. I'll probably just use a square to get them somewhere near to there. It sort of doesn't really matter too much, but actually I'm just going to do it by eye, to be honest, because there should be a bit of wiggle room. I've got these M10s that are going to go in there. Hopefully they're long enough. Yeah, I think so. So that's about there. Let's see if I can, I'll just mark the line like that, and then I'll centre punch it in the middle of that line on both of them. So I've got the two lines there. All I need now is a centre punch, which seems to be missing from the armoury. There's an automatic one there, but I prefer one with a hammer if I can. It's always a good idea to get all your tools together before you start a job. Centre punch, there's a proper one, and a hammer. There's a little hammer there, which is just the ticket. So in the middle of there, that looks about right. Give it a nice big centre punch, and that one there, about there. That looks about right too. There we are. Okay, this is slightly too, the actual table itself, as you can see, is just a little bit too high, and this is only a bench top drill press, so I'm going to have to swing that out of the way and then mount it on the base. So I've put a couple of blocks of wood just to hold it about the right height, which that is, and we'll come down and we'll drill that. So I'm just going to go straight in with this, because the centre drill that I would normally start it off with isn't quite long enough from where it reached. So again, I'm just going to get some anchor lube on the job. lube. And the drill. Now I've been having a think, and I think what I might do is I might just tap these, because there's plenty of meat on those. My bolts aren't terribly long, actually they probably are long enough, but I think it would just be neater if those were just tapped into there. It just makes life a little bit easier. So yeah, it's nice that you can use tapered shank drills in here. It makes life a little bit easier. Let's a bit of the old ankle lube on there, just to ease the way. So, just need to tap those out. There we go. As I say, I'm just going to try and eyeball this, because I haven't got a tapping block or anything. But this is a first tap, so number one tap, or whatever it's called. So it should be okay. That's going in fine. So. That's the first one through. Seems fairly straight. It is very annoying if you do get a tap in at an angle. There's nothing that makes a piece of work look more sort of badly built than when the tap's gone in at an angle. It looks pretty rubbish, and I hate it when it happens. Sometimes it catches you unawares when you think it's straight and it's not. That looks reasonably straight. There we go. That looks pretty good. Yep. And three. As I don't want to put the chuck back in because it's a bit of a faff, and I'm idle. I think that'll fit. It does. Just polish that edge up a little bit with. There we go. That's a bit better. So, there we go. That just neatens that up a bit more. That's better. It's a bit quicker than Right, so there's me. They're going nicely. So one in there. Probably better off with a washer on top of there. So let's get a washer. So let's get two. One for that side. And another bolt. And on that side. Let's tighten these up. Oh yeah, that's lovely. There we go. That's lovely. That's going to do the job. So that's one down, one to go. Right, well I've done both of them now, so they've both got the bearing blocks screwed and tapped onto the top there. What I've also done is, and I've drilled these two holes at the bottom, those are to hold them down onto the roof on the observatory. So one thing to tick off the old list. Be back in after a coffee break to continue with the next job, which I think is going to be, where is it? Here it is. The next job on the list is going to be, this is the boss that goes on the 2-inch pipe, which holds the flap in place, and this is the sprocket. I've already machined that so that it registers on the sprocket like that. So what I do need to do, these radial holes that are in here don't line up with this sprocket, so I'm going to offset that by 90 degrees, oh sorry, 45 degrees, and I'm going to re-drill 4 holes, re-drill and tap those, and I've got some M8s which are going to bolt through there to hold this sprocket onto this, so that that's now capable of being bolted onto the tube and will allow the chain to then take the actual torque of the flap via a chain to this countershaft, to the countershaft which runs on between these two bearing housings. So quick cup of coffee, and I'll be back in 5 minutes to do some. Okay, in order to drill out this this bolt pattern, what I'm going to do is mount it on this little rotary table here, and in order to centre it, what I've got is I've got a little Chinese arm for my indicator, and because when I actually turned this register on here, I did it basically with the boss chucked onto this surface here, so it's with reference to that and this edge here. So I'm just going to roughly clock it on here using this. I don't know if you can all see that, but let me just. I think this is right in the way, isn't it? Let me just drift that out so you can see what's going on. Just take this out. There we go. So you can see the dial indicate the indicator I've got about here. Now I'm just going to have to work out where the high spot is first, where the highs and lows are. So I think that is the low point, and if I go around here, so the low point is about there, which is, let me just get the 0, low point's about there. So if we go around to here, the high point, there's paint on there's some sort of crud on the inside of it. It's not particularly clean, so this isn't ever going to be super accurate, but it'd be fine for the bolt circle. Where do we get to? We've got so the high point is somewhere around here, which is 40. So if I put this halfway, 20, that's where we need to get to. So that's 0 there. It seems to be more dictated by the crud. but that's on around there somewhere, and that is, there's a big low point there, isn't there? But that there, hang on, let me just work out which way we've got to go. We've got to go in that direction, so I need to just slightly slacken these two here, and slightly tighten these two here. Oops, which is undoing, of course, because we're clamped from the, because we're clamping on the inside of the bore. You've got to undo them to tighten them effectively. So that about there and that about there, and let's just have a spin round now and see where that gets us. So that's 5 thou. Actually this is in 0.01 millimeters, so that's, yeah. So we've still got a bit of a sweep, so if I come around here, I think this is the surface, the unevenness of the surface, which is part of the problem here, because we seem to be, right, that this is a low area here, so we'll just tighten up. I think we'll just tighten these two up here. Let me just get back to here. It should be somewhere near now. And that's a bit of a rough area. So we're within a couple of thou here, which for the purpose of what I'm doing is probably absolutely fine. So let's put that out of the way. Right, that's my first hole. And then we need to do, it's 60 revolutions all the way around, so 30 would be half, so 15 is going to be 90 degrees. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and this will be 15, which is there. So just lock that off. That looks about in the right place, somewhere in the middle of those two. I'm just going to tell you what I can do, just to double check. So if I put put this on here over the hole, that should be in the middle of that hole, and it is. So I'm pretty happy with that. Pop that off. Right, for the next hole. So, does that look okay? Yeah, that looks fine. I'm just going to go straight with the 7mm going into here. I might keep the holes blind. I think I'm going to keep those holes blind, just so that so slacken that off. 15 turns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. So, oops, 16. That should be 15. 15. I'm just going to, as I miscounted there, I'm just going to, that's the hole there. So let me just mark that. That's my actual hole, not the cock-up hole next to it. 15, that gets us into the right position. Locked up. Right, that should do it. That's the four holes on the register around with the holes in there, and that looks fine to me. Just got to tap those and screw it all together. Let me just find my chunky key. So just going to go off and tap those. Right, I'm just tapping these at the moment. This is number 2 tap going through. Or is it number 1? I can't remember. I think it's number 1. Right, that's the 3rd. This is the first tap of the 3. So this one's got the shallowest of the this one has the shallowest of the, you can see if you look there, it's got quite a shallow thread on it, so that makes it into the work more easily. And then we follow up with taps that have got deeper threads on them. This is the last one of the 4 holes. Just make sure that goes in straight. Seems to be straight now. So because you notice that occasionally I go backwards. So the reason for that is that the chips build up inside the flutes of the tap, and the chips themselves can block into the thread, and if you get them blocked, you run the risk of breaking the tap. So in fact, what I was taught at college is it's one revolution forward, half a turn back, and that ensures that the chips are cleared from the flutes, and you shouldn't break a tap doing that, but it's very easy to break a tap. I'll show you what I mean by the flutes getting filled with chips. If you look at this, when I get this out, you'll see, look, there's a big lump of, see those flutes there, they're full of chips. They're the chips from cutting the thread. Now if you allow those chips to build up actually in the threads themselves, the tap can jam in the work, and once that happens, you can run the risk of breaking the tap. Now the taps are very hard, they're hardened. This has got some titanium type coating on it as well, but they're hard. Now what that means is that they're also brittle, and they have a tendency to break around this area here where the flutes and all of these threads are. And what happens is if that breaks off inside there, it's the devil's own job getting it out, because it's hard as nails and you can't drill it and you can't do anything with it, and it's not a nice thing to, in fact you would almost just have to start again on this. It would jump the job. Right, so that was the first tap. That's got the shallowest of the threads. I'm now going in with the second tap, I think. Let me just check. Yep, this is the second tap. Now the threads on this are ever so slightly bigger on there, deeper, so they cut more metal this time. So this is a good strategy for preventing you from breaking any taps. You use taps which have increasingly more depth of cut on them. So this one goes in a lot easier because it's following the thread of the first one. So generally, let me just tilt that down slightly. Generally, a lot easier with a number 2 and number 3 tap. But it's always a good idea now and again just to back off half a turn, just to make sure the threads are jamming up. You can feel it tightening anyway. That's one of the nice things about hand tapping. You can feel the flutes filling with, or rather you can feel the chips building up in the thread, and then when they get too tight you just back off slightly and it all goes slack again. And when you're through, you know, like there, I know that I'm pretty much through now. These are going right through the other side, so a lot of the chips are actually falling through the bottom here. You probably see them from where you are, falling through the bottom of the hole. Just wind that out. So that's that one. I've already tapped that one completely, so these 3, these are the three that need doing. Anyway, I'll carry on doing this, and I'll show you when it's done. Right, now that I've got these 4 holes tapped, let's go ahead and bolt it on. So that's on the register there. 4 bolts here. By the way, I just sort of ran the countersink with the battery drill just into those holes, just to neaten up the edges. It makes the bolts go in more easily. It allows the bolts to locate in the holes, and you can see by, hopefully, by doing them on the rotary table, the whole thing on the rotary table, getting them in the right place, you can see that they're absolutely, it's definitely worth the effort of clocking it in so that it's concentric, and so that these bolts fit as they should. Let's just spin these on quickly with the socket. Obviously this isn't spinning at high speed, so the amount of off-centerness is sort of not terribly important. That's the wrong size. What are we after? That's the right size. Not terribly important, simply because this is only turning 90 degrees, so it doesn't have to spin at high speed or anything. Tighten these chaps up. That was not tight enough. I must have not gone quite deep enough on the last thread. So I'll do it like that. That's a form of lock. There we go. So that's nice and bolted onto there. That's not going anywhere. It's centered on the inner ring there. You can see that it's nice and centered, and that goes onto the existing shaft that the actual dome flap is on, and then these bolts screw through into the pole and locate into some grooves in there. So that's another job to tick off the list.